In this video, we'll do integration by parts. We'll not do a traditional way of integration by parts that you have been doing in your school and college calculus courses. We'll do a little bit unique way of doing integration by parts. Let's say if you have two functions, u and v, and we want to integrate them with respect to x. Let's say u and v both are functions of x. Integration by parts, the way we are doing, the formula says that you can write this as u into integration of v with respect to x minus integration of, you have two values over here in this integral, in the second integral, and you have with respect to x. In the first value, you differentiate that u with respect to x, so you have d by dx of u. In the second placeholder, you have integration of v with respect to x. That's the formula that we'll use for integral by parts. This formula will make your problem solving at least 2 to 3 times quicker than your traditional one. You'll see how with the help of an example. Before moving to an example, let's look at the eyelet rule in order to decide what should be u and what should be v. You know, in differentiation, you already know that u and v are in one way sequence doesn't matter of u and v. Whatever u and v you select in differentiation, it doesn't matter. But in integral, it does matter what u and v you select. In order to decide the sequence of u and v, you have a rule called as eyelet. I-L-A-T-E. Now, what this rule does, before understanding the rule, let's go into the full form of that abbreviation. I stands for inverse trigonometric functions. Okay. L stands for logarithmic functions. A stands for algebraic functions. T stands for trigonometric functions. And E stands for exponential functions. I hope that makes sense. Now, what this eyelet rule tells you is whatever comes first is your u. Okay, so you go from left to right. Whatever comes first is will end up becoming your u. Let's look at that with the help of an example. Let's say if we have integration of log x times x with respect to x. Okay, let's say if we want to do this integral. Now, log x is nothing but logarithmic function, obviously. Okay, and x is nothing but algebraic function. Okay. So in this case, log is coming first and then there is algebraic. So that means log will become your u and x will become your v. Remember, whatever comes first is your u and the other one is v, obviously. Now let's apply this formula over here and see how do we integrate log x times x. So the formula says you keep the u the way it is initially. So you keep log x the way it is. Then you integrate v with respect to x. So integral of x with respect to x. Then you write a minus. Then you write an integral. In this integral, you have two terms. Remember, in this integral, you'll have two terms and you integrate them with respect to x. The first term is a differentiation of u with respect to x. So the differentiation of, so d by dx of log x with respect to x. Okay, one thing to remember here is log x is the natural log. Okay, I'm assuming that it is ln x really. The log x is a natural log. Okay, so in the first term, you have differentiation of u with respect to x. In the second term, you have integral of v with respect to x. So integral of x with respect to x. Now it is so simple to integrate this at this point. You have log x times integral of x with respect to x is nothing but x square by 2 minus integral of natural log of x with respect to x is, or sorry, differentiation of natural log of x with respect to x is 1 over x, and integral of x with respect to x is x square by 2, and we have with respect to x. Now let me write that x square by 2 first and then write log x, obviously natural log. Okay, it's natural log everywhere, and this x can get cancelled. You will be left with 1x in the numerator. This half is constant, can be taken out of the integral. So you have half integral of x with respect to x. Oh, there is a minus sign in between over here. So what you have is x square by 2. Let me just write it as ln x at this point, minus half. And integral of x is nothing but x square by 2. Let's add the constant of integration. See, and this is really your final result. You can just combine this 2 and this 2 to give you 4. So you have x square ln x divided by 2 minus x square divided by 4 plus constant of integration. See, and this is nothing but your final result. I hope that makes sense. If you understand the concepts that I'm teaching you, can I request you to like this video and subscribe to this channel? I will make the full PDF of this solution available in the description. So do check the description out as well as the first comment out. If you want to book a personal one-on-one tutoring with me, please do check the first comment and the description as well. I do post math and calculus content every single day. So if you don't want to miss it, please do consider to subscribe. I'll see you tomorrow.